Hi, welcome to today's chemistry class. So today we'll be looking at another aspect of chemistry. I would appreciate if you always like my video and subscribe to my channel. You can also share this video to family and loved ones so they can also benefit from the message we are trying to pass across. Okay, so today we want to look at more concepts. This is like a second part of the first video that I posted on more concepts. So the initial part explained about the molar mass, the relative molecular mass, the relative atomic mass, and some calculations under this molar mass, relative molecular mass. So if you haven't seen that video, you can go to my channel, Finance Online Class, and look for the video on more concept 1. So today we are going to be diving into more concept 2, and we will be understanding and calculating more. So I will quickly have a kind of brief recap of what more is all about. So you will be learning what more is in chemistry, then why is the more important, then also how does the more relate to counting particles. Okay, think about it. Can you imagine counting individual atoms? How might the more make this easier? We all know that atom is a very, very small entity. The atom is so small that it is difficult for us to see with our naked eye. So it simply means that despite the size of these atoms, we still need to look for a way to measure, to count the particles or the atoms itself. Okay, so and that's what led us to this mole. So we say a mole is a unit of measurement. It's fundamental of measurement, and that we use in chemistry basically when we are trying to quantify the amount of a chemical substance. Okay, so now let's talk about the mole and formulas. So we'll be looking at calculating moles from a given mass. We have an example here, and we also have an assessment. However, we'll try to look at the example first, then thereafter we can try the assessment. So let's look at this example. Calculate moles of water in 18 grams of water. So they are asking us to determine how many moles of water are we going to have in 18 grams of water. Now remember, when I was talking about mole, I made mention of mole having, we can have particles in mole. One mole contains 6.02 times 10 raised to power 23 particles, and I made mention that that 6.02 times 10 raised to power 23 particles is also referred to as the Avogadro's constant. Now there is always a relationship between the mass, the molar mass, and the mole. So in this case, whenever you hear gram, know that we are talking about the mass. Whenever you hear gram per mole, it has to do with the molar mass. So we have something here that says calculate the mole of water in 18 grams of water. So it simply means they want us to determine the amount, the mole that is going to be present in 18 grams of water. Now there is a formula that we can always use. However, first we need to determine the molar mass of water. So from our previous video, if you actually followed, you should be able to calculate the molar mass of water. So we know that in this formula of water, which is H2O, we have 2 atoms of hydrogen, then we have 1 atom of oxygen. So that's 2 times 1, then plus the atomic mass of oxygen, which is 16.00. So that gives us 18.02 grams per mole. So the molar mass of water is 18.02 grams per mole. So we have this formula to calculate mole, which is mole is equals to mass over molar mass. Mole is equals to mass over molar mass. Remember, from the question we are asked to calculate mole. We have been given mass, which is what? 18 grams, and we have calculated our molar mass from here, which is also 18.02 gram. So the rest is just for us to substitute the value. So we have mole of water is equals to 18 grams divided by 18.02 gram per mole. Please always remember to put the units so that they can cancel out. So this gram will cancel this gram, so we will be left with mole. Final answer will be 0.999 mole. So 18 grams of water is approximately 1 mole of water. Please, whenever you are trying to write your own formula, please always refer to the substance or the compound you are calculating. For instance, they asked us to calculate for water. In the formula, I'm referring to water as mass of water divided by molar mass of water. Okay, so we have been able to solve this question. Now is your turn to try the assessments. If you have 50 grams of sodium chloride, molar mass is equals to 58.44 gram per mole. How many moles do you have? So please quickly pause this video and try it. In this case, now they've given you molar mass, so it's just for you to apply the formula. Okay, after you are done, check the answer. Okay, if you have this, or give yourself some clap. If not, try as much as possible to check your step again and see where you got it wrong. Okay, we are moving forward. Let's talk about the mole and Avogadro's number. Can you recall what Avogadro's number is? Okay, did I hear you say 6.02 times 10 raised to the power 23? Yes, that's Avogadro's number, and is the number of particles present in 1 mole of any substance. Okay, now let's have an example. Calculate the number of particles, Roman figure 1, present in 5.5 gram of manganese. This symbol for manganese is Mn. Then Roman figure 2, calculate the number of particles present in 44 gram of iron 2 sulfide. Symbol or chemical formula is FeS. So in most cases, they usually give us the atomic masses of the elements, constituent elements of the compound. For instance, you can say manganese, they've given us the atomic mass to be 55, oxygen to be 16, then iron to be 56, and sulfur to be 32. So they expect you to be able to use these values to solve the question. Okay, now let's see how the calculation goes. Still the same formula, mole is equals to mass of a given substance in gram over the molar mass of the compound. Sometimes you see people representing mole with N, so it's still N is used to represent mole. So we have mole of manganese is equals to 5.5 divided by 55 gram per mole. Remember, we are trying to solve the Roman figure 1 question. So we have 0.1 mole. Remember, the question says calculate the number of particles. Actually, the formula to calculate number of particles is number of atoms or particles is equals to moles times Avogadro's number. Mole times Avogadro's number. Now, why we have to first of all calculate the mole of manganese is because in the question we have here, all the parabolas given to us, we don't have the value for mole. So, but the formula says to calculate number of particles, you must multiply mole by the Avogadro's number. So we already know the value for Avogadro's number, but we don't have mole. So it simply means we have to calculate our mole using the formula mass over molar mass. So having gotten the mole, which is 0.1 mole, we can now have 0.1 times 6.023 times 10 to the power 23. So that gives us 6.023 times 10 raised to the power 22 particles. So the number of particles therein for 5.5 grams of manganese is 6.023 times 10 raised to the power 22 particles. Okay, so please always remember that they can use this particles interchangeably. Sometimes they'll say calculate the number of particles, sometimes they'll say calculate the number of atoms, sometimes they'll say calculate the number of molecules. In our case, you are still going to follow this formula. As you can see here, number of atoms or number of particles. Okay, so I will need you to try to solve the second question, which is 44 grams of iron to sulfide. Try to attempt it and see how far you can go with it. You can quickly pause this video. Okay, your answer should give you 3.012 times 10 raised to the power 23 particles of iron to sulfide. So if you got this correctly, you can proceed. If not, check your step and retrace your step. So let's talk about the mole and volume. The mole and volume. Now, so far so good. The one we've looked initially has to do with, talking about mass. Basically, when it has to do with solid, But in some cases, you also want to calculate for gases, that is, compound that are gases. When we are now talking about gases, we'll be talking about volume. So we are now trying to look at the relationship between mole and volume. Now, for every gases, I repeat, for every gases at STP, when we say STP, it simply means standard temperature and pressure. For every gases at standard temperature and pressure, they occupy 22.4 dm³. It simply means that 1 mole of any gas will occupy 22.4 dm³. That is, the volume is going to occupy is 22.4 dm³. Okay, now we will be looking at calculating volume from moles of gas. Then we have an example here that says calculate the volume occupied by 5 moles of carbon dioxide at STP. We also have an assessment that says what is the volume of 3 moles of CO2 at STP. So let's treat the example together. Calculate the volume occupied by 5 moles of carbon dioxide. Remember, as I said that a gas is capable of occupying a particular volume. Now, but we have a standard. For the reason why we usually have standard in chemistry is basically for us to have a uniform outcome, so that you won't be having some external factor that after all, I did my own in Nigeria, that one did his own in abroad or maybe UK or somewhere else. But when we have this standard values across board, so we know that even though you are abroad, UK, any other part of the country or the continent, you are working with the same value and you will be getting the same results or similar results. Okay, so that's why in chemistry we basically make use of a kind of standard routine across board. Okay, now let's look at this. calculate the volume occupied by 5 mole of carbon dioxide at STP. Remember I said 1 mole of any gas will occupy 22.4 dm cube at STP, at standard temperature and pressure. Let's look at the solution. So we have 1 mole of a gas at STP is equals to 22.4 dm cube, and we are asked to calculate for CO2. The volume occupied by 5 mole of CO2. So we know 1 mole of CO2 is equal to 22.4 dm cube. Since we said any gas, CO2 is a gas. So 1 mole of CO2 will occupy 22.4 dm cube. Now, if 1 mole occupy 22.4, 5 mole of CO2 will now occupy how many? So we regard that as X. You just cross multiply. So it's going to be, if we cross multiply this, it will be 5 times 22.4, which will be equals to 1x. So, and that's why we arrive at this 5 times 22.4. Then your x is equals to 112.0 dm cube at STP. So the volume of CO2, the volume occupied by 5 mole of CO2 is going to be 112.0 dm cube. Okay, I believe that's clear enough. So always remember this value. 1 mole of a gas at STP is 22.4 dm cube. Now it's your turn to try the assessment. Quickly pause this video and calculate the volume of 3 moles of CO2 at STP. Check your answer. Okay, 67.2 dm cube. Alright, we are moving forward to the next step. Okay, the mole and volume still continue. Now we have another example here. Calculate the volume at STP which would occupy 2.56 grams of S8 vapor. We have been given the atomic mass of sulfur to be 32. Now I want you to think, in this case now we are having us to calculate the volume at STP which would occupy 2.56 grams of S8 vapor. What do you think? They are not talking about more here, and they didn't give us more, but we have mass. They want us to calculate volume. What do you think we can do? Can you pause this video and try to think? Okay, now let's have the solution. First, since we don't have our mole, but we have mass, which is 2.56 grams, we can calculate molar mass. Remember, sulfur is having 8 atoms of sulfur here, so you have to take that into consideration when you are calculating the molar mass. So we have mass divided by molar mass. So molar mass is equal to 32 times 8. Then mole of S8 is equal to 2.56 grams, that is the value we have here, divided by 1256 grams per mole, which is the molar mass of S8. So that gives us 0.01 mole. So we cannot go back to the volume, calculating volume now, since we already have our mole. So we cannot say that volume dmq, remember they asked us to calculate volume, is equals to mole times molar mass. Mole times molar volume. Remember, molar volume is 22.4 dm cube. So we have 0.01, which is our value for mole, then times the molar volume, which is 22.4 dm cube, and you have this as your final answer. Okay, so now it's your turn to try this. How many grams of gas are present in 5,600 centimeter cube of chlorine gas at STP? So I need you to try this quickly. Please always take into consideration on your thinking cap for you to be able to solve question in chemistry. So once you are done, take a look at the answer. So we have 17.75 gram of chlorine gas. Okay, do you get that? If not, retrace your step and try it again. Calculating reactants and products from chemical equations. Now you see we can actually calculate the amount of reactant needed or the amount of product formed mere looking at a chemical equation. Now you see the reason for this in industries, maybe chemical industries, they make use of this to prevent wastage of reactants, or to know when they are to stop production. For instance, if they can calculate the amount of product that will be formed, they can easily say that, okay, we just need to react these chemicals together and it's going to give us this volume or this quantity of products. So with that, it's going to prevent them from wasting their resources, their raw materials. It's also going to prevent them from wasting time. You know, overall, it's going to be economically visible for them to go into production. So we can actually calculate reactants, amount of reactants or products from just the chemical equation. So let's go. Take a look at this question we have here. Calculate the mass of aluminium formed when 51 grams of aluminium are electrolyzed. The equation of the reaction is, okay, so you can see the equation of the reaction below. So this is actually the solution, but let me just explain one or two things from the equation. Now looking at this equation, you can actually determine more from this equation, the mole ratio. Whatever value you have as a coefficient, like these two you have here, represent the mole of this aluminium oxide. Then these four we have here represent the mole of the aluminium. This three we have here represent the mole of the oxygen. Okay, so now we can easily say that we have 4 mole of aluminium and 3 mole of oxygen. So we can say the mole ratio here is 4:3. So why the mole ratio for this is, the mole of this is just 2. Okay, so now having said this, you can now know that from the chemical equation you can determine the mole. So we can easily say that for every for 2 moles of aluminium oxide, it will give 4 moles of aluminium and 3 moles of oxygen. So if I have this equation, I can use this as reference to calculate maybe a higher mole or a lesser mole. For instance, if I want to produce, let's say, higher mole of aluminium, let's say for instance 6 mole, I should be able to use this chemical equation. Or if I want to produce a lesser mole, I should be able to use this chemical equation. Okay, so let's see if the explanation from the calculation we have here. So first we have to calculate the molar mass of aluminium. So I believe by now you should be conversant with calculating molar mass. So we have 102 gram per mole. Then we also need to calculate the mole of aluminium oxide. So we have, now get it straight now. Reason why we have to calculate the mole is because in the question it says calculate the mass of aluminium formed when 51 gram of aluminium are electrolyzed. Okay, sorry, this one ought to be 51 gram of aluminium oxide. Let me correct that. Okay, this should be aluminium oxide. Okay, so now calculate the mass of aluminium formed, that is the mass of this aluminium that is formed when 51 gram of aluminium oxide are electrolyzed, that is this aluminium oxide here. Now you see in this case now the 2 mole we are having here is not telling us anything about the mass, but they are now giving us that if we have 51 gram of aluminium oxide being electrolyzed, how many what's going to be the mass of aluminium that will be formed. So that's why we have to first of all calculate the mole of aluminium oxide in relationship to this 51 gram. So we now have 51 gram divided by the molar mass of aluminium oxide, and that will give us 0.5 mole. So it simply means that we have 0.5 mole of aluminium oxide. Now consider the molar ratio from the equation. 2 mole of the aluminium oxide produces 4 mole of aluminium. As you can see here, 2 gives 4. Then if this 2 mole of aluminium oxide gives us 4 mole of aluminium, 0.5 moles of aluminium oxide will now give us what? So we term that X. So we have X is equal to, you just cross multiply, so it's going to be 0.5 moles times 4 mole, so divided by 2. Just for you to cross multiply this. So we now have final answer for the mole of aluminium to be 1 mole of aluminium. Now we are not done. Remember the question still says the mass of aluminium. So now we have the mole of aluminium. It's easy for us to now calculate the mass using the formula mole is equal to mass over molar mass. So we cannot have mole. We know that if you make mass the subject of the formula, is going to be mole times molar mass. So we have 1 mole, that is the value we got here, times 27 gram per mole. This 27 gram is the molar mass of aluminium. So final answer, mass of aluminium is equal to 27 gram. Please remember the unit of mass to be gram, the unit of molar mass to be gram per mole, and the unit of mole is mole, M-O-L. Okay, so that's talking about solving this chemical equation, getting mole and mass from chemical equation. Okay, I think it's time for assessment. A reaction is carried out between potassium hydroxide, they have given us the molar mass to be 56, and sulfuric acid H2SO4 98 is the molar mass. Below is the balanced chemical equation. Okay, You have the equation here. 5.9 grams of KOH were used in the reaction. Predict the mass of potassium sulfate produced. They've given you the molar mass of potassium sulfate to be 174. Okay, so please try this and see how far you can go. So what you are expected to do is to calculate the mass of potassium sulfate produced. So this particular compound we have here, that's what they want you to calculate. First, always remember to check the mole ratio in the chemical equation. So this is another assessment for you. Calculate the number of moles in 100 grams of calcium carbonate. Molar mass is 100.09 gram per mole. You have your answer here, so you can always check your answer to see if you are right or wrong. So this one is under mole and Avogadro's number. It's also for you to try. How many atoms are there in 3 moles of aluminium? Final answer is also being given for you to check. Mole and volume. Find the volume occupied by 0.25 moles of nitrogen gas at STP. In the reaction nitrogen plus hydrogen to give ammonia, how many moles of ammonia are produced from 2 moles of nitrogen? Okay, so we have been able to look at calculations in mole. We have looked at moles from mass, importance of knowing the molar mass. We've also, considered so many other aspects of mole calculations. Now, why do you need to know the molar mass to convert from grams to mole? Okay, just take a look at this. Why is Avogadro's number so large? You can also pause this video, try to think and see the response you likely give yourself before you check the answer. Okay, so there you go. Why do we use STP conditions when talking about the volume of gases? I think I've made mention of this in the course of the explanation, but you can also think of your own answer. Alright, so we have been able to look at much today in calculation in mole. What would happen if we then balance the chemical equation before performing more calculations? What do you think? Real life application in depth. How chemists use the mole in pharmaceuticals, the roles of mole in industrial chemistry, environmental applications, calculating pollutant levels. How might a chemist use the mole concepts when creating a new medicine? This has been one of the ideas I've shared, but you can always think of something else and check your answer. So this is a final assessment for you on mole calculations. So please try as much as possible to attempt all these assessments. It's going to help you to get acquainted with solving questions on moles. Okay. So finally we have our conclusion. The power of the mole. So far, understanding the mole helps us quantify the microscopic world. When we mean microscopic world, it simply means more atoms are so small that we can't really see them, but the knowledge of mole helps us to quantify atoms. The mole is the bridge between the atomic scale and the microscopic world. Now reflection. How has learning about the mole changed your perspective on chemical quantities? Okay, that will be what you take home. That's all for today's class. Remember to like this video and subscribe to the channel, share to family and friends. Thank you. See you some other time. Bye.